Hi everyone. Today we are going to start with one of the most important topics of strength of material, which is nothing but principal stresses, as you can see in the board. Now, we learned in the previous sessions what do you mean by stress, what do you mean by strain, how to evaluate stresses and strain, how to evaluate thermal stresses, how to evaluate volumetric strain. Okay, you can have a system which can be uniaxial, can be biaxial, can be triaxial. So when you talk about 3D system and when you have stresses such as sigma x, sigma y, sigma z and corresponding shear stresses, that's a triaxial system. Okay, but what do you mean by principal stress? Before going to that topic, okay, when you can have a combination of normal plus shear stress. That means in a given system, for example this duster, I can have sigma x acting externally because of some external force. I can have sigma y because of some external force. I can have sigma z as well. Okay, so I can have three normal stresses in a 3D system. But I can also have shear stresses, tau x, y, tau y, z and tau z x as well. Okay, when you have such combination of stresses, which is normal plus shear, the system can be biaxial, uniaxial or triaxial. How to evaluate the maximum normal stress and how to evaluate the maximum shear stress. So when you have a combination of normal plus shear stresses in a given system, the system can itself be a uniaxial system, a biaxial system or a triaxial system. When you have such kind of systems, how to evaluate maximum normal and maximum shear stresses, and the procedure and the way to evaluate maximum normal and maximum shear stress is via principal stresses. So what do you mean by principal stresses? I have written here, principal stresses are local extremes. When I talk about local extremes means what? They can be maximum or it can be minimum. Okay, तो ये आइदर मैक्सिमम वैल्यू हो सकती है या तो एकदम मिनिमम वैल्यू हो सकती है, और ये एक्सट्रीम वैल्यूज है, मैक्सिमम एंड मिनिमम. तो प्रिंसिपल स्ट्रेसेस फर्स्ट एंड फॉरमोस्ट दे आर नॉर्मल स्ट्रेसेस. They are normal stresses and they are maximum and minimum values of normal stresses. Okay, when I say local, that means, let's say I have a plane here. It's a 2D system. I have some sigma x acting here. I have some sigma y acting here, and there is some external tau x y acting as well. Because of this combination of stresses, normal and shear, in a 2D system, so it's a biaxial system where you have a normal stress and a shear stress together acting. I want to evaluate the value of maximum normal stress. So that value of maximum normal stress is known as principal stress, and it is local to this particular planar figure here. So I can have maximum normal on this particular plane. Okay, I can have maximum normal on any other plane, let's say this particular plane. So this can be my maximum normals, and both these stresses are known as principal stresses. Okay, so they are the local extremes of normal stresses which can have minimum and maximum value, and they occur on any plane through a particular point. So you have a plane here, they occur on any plane. Okay, and the plane on which they occur are known as principal planes. Okay, so principal planes are those planes on which you are going to have maximum and the minimum values of normal stresses, and this maximum and the minimum values are local to this particular plane. Okay, so planes on which you have maximum and the minimum normal stresses are known as principal planes. Other way of defining principal planes is planes where shear stresses are zero. Okay, we'll get to this point. There are also those planes where shear stresses values are zero. So when I showed this diagram here, I said sigma m2 and sigma m1 are principal stresses. Okay, and they're acting on these two planes. So I have here plane 1 I have here plane 2. So these two planes now become principal planes because on these planes we have principal stresses acting. So according to other definition of principal planes, which says those are those planes where shear stresses are 0. So on these planes you are not going to get any shear stresses. That's a very important point that it should be noted. Okay. So the planes where shear stresses are 0 are known as principal planes, and the stresses, normal stresses acting on the principal planes are known as principal stresses. Once again, okay, so again maximum and minimum normal stresses, they are always normal stresses. Remember this, principal stresses are always normal stresses. So when do you evaluate principal stresses? Okay, first and foremost, one should understand when to evaluate it. So when to evaluate it? When you have a combination of normal and shear. Okay, and you may have a biaxial, uniaxial or triaxial system. So when you have a uniaxial, biaxial or triaxial system on which you have a combination of normal and shear stresses externally acting, okay, then if I want to evaluate what is the maximum normal and what is the maximum shear, then I will go to the principal stresses phenomena or principal stresses procedure. Okay, why the question arises, then why do we require this maximum normal and maximum shear? The answer to this is very simple. We design on maximum conditions. So when we design a system, we consider what is the maximum stress which are coming into the system, coming on to that particular system. So it can be maximum normal or it can be maximum shear. So for the purpose of design, I might need either maximum normal or I might need a maximum shear stress. And to evaluate that in a complex system which has a combination of normal and shear, the only way to do it is via principal stresses. Okay, I'll repeat this sentence once again. So for the purpose of design, we either have to evaluate maximum normal stress or we have to evaluate maximum shear stress. Okay, so the complex system can be either uniaxial, biaxial or a triaxial system which has a combination of normal and shear stresses. In order to evaluate on such a system what is the maximum and what is the maximum normal and shear, we use the fundamentals of principal stresses. And what are those principal stresses? Most importantly, they are normal stresses. They are normal stresses. I'm stressing out these words again and again. They are normal stresses. And they are the maximum and the minimum values of normal stresses. Okay. So there are the local extremes, maxima and the minima. And this normal stresses will only be acting on those planes which are known as principal planes. So principal stresses act on principal planes. And how do we define principal planes? Planes on which maximum minimum normal stress acts, or planes where shear stresses are 0. Okay. So this is the definitions. These are the definitions of principal stresses and principal planes, and when to evaluate principal stresses and principal planes. Okay, we'll learn about the formulas of principal stresses and principal planes in the next